Unit 7 is similarity. Today's lesson, 7.1 Dilations. Objectives. The students will be able to draw dilations using given scale factors, be able to draw dilations in the coordinate plane, and that's mostly the focus. And students will be able to understand the dilation of a line segment is longer or shorter in the ratio given by the scale factor. There's also going to be several delta math examples to prepare you for your assignment. Dilations. A dilation is a reduction or enlargement of a figure with respect to a fixed point called the center of dilation in the coordinate plane to the left. Center of dilation is the origin, and that is predominantly what we will be using for the center of dilation. A dilation is an example of a non-rigid motion in that it does not preserve congruency. All the other transformations we did, reflection, translation, rotation, were all rigid motion in Unit 3. Now it's non-rigid with the dilation. A dilation produces similar figures, and this entire unit's on similar figures. All corresponding angles are congruent, and all corresponding sides are proportional. All corresponding angles are congruent. Yeah, we'll need that later. Scale factor. A scale factor indicates how much the figure will enlarge or reduce. Variable for scale factor is K. When K is greater than 1, the dilation is an enlargement. When K is between 0 and 1, not equal to 0, not equal to 1, but somewhere in between, the dilation is a reduction. A scale factor of 1 does not change the figure, and then it would be rigid motion. Dilation rule. If the point P, X, Y is the pre-image of a point, then its image after a dilation centered at the origin 0, 0. This works when it's centered at the origin. With scale factor K, we'll follow this rule. All points x, y go to the point k times x, k times y. So all you have to do is multiply both the x and the y of the point by the scale factor. Dilations in the coordinate plane. Enlargements first. Directions. Graph and label each figure. I have the original figure there for you and its image under the given dilation. So we have triangle RST with vertices. R's at -5, 1. S is at the point -3, 4. And T's at the point 2, -1. K is 2. So the points are going to involve an enlargement. We're expanding to get a larger figure. So R is at the point -5, 1, S -3, 4, T 2, -1. I like to keep them organized like that because I think it's easier to do that. So we are going to multiply both the x and the y by 2. So to get r prime, we multiply -5 by 2 and 1 by 2. We get -10, 2. Do the same thing with s, -6, 8. And point t prime is going to be 4, -2. Connect the dots, and we have our triangle, our image after the dilation. Number 2 is a rectangle, ABCD. Its vertices are at A, -3, 0, B's at 1, 2, C's at the point 2, 0, and D's at the point -2, -2. K is 3, so we're enlarging again. It's expanding to get larger. Our original points, just to get them all organized, it's already graphed there for you. It's listed up above. But to get our enlargement, we need to multiply both the x and the y by 3. So I think it's easier when they're all lined up like that. So A prime is going to be at -9, 0. B prime's at 3, 6. C prime's at the point 6, 0, and D prime's at the point -6, -6. Connect the dots to make a rectangle. A prime, B prime, C prime, D prime, that rectangle is now the dilation after using a scale factor of 3 on our original rectangle. Here's another one. This time it's a rhombus. We're going to have all these quadrilaterals in Unit 6. Rhombus JKLM has those vertices. Let's see. Didn't read the directions. These are going to be reductions, and first clue would be the scale factor K is 1/2. So let's bring down our points, J, K, L, and M, just to get it organized. Now what we need to do is multiply both x and y by the scale factor 1/2. And what's really nice is they're all even numbers, so we're not going to get any decimals. J prime would be at the point -5, 1. K prime is going to be at the point -1, 4. L prime is at the point 3, 1, and M prime's at the point -1, -2. Connect the dots. And there is the image under the dilation with scale factor 1/2. Triangle WXY in example 4 has vertices W at -4, 8. X is at the point 10, 0, and Y is at the point -2, -8. K is 1/4. Yes, it's going to get smaller, even smaller than the last one, shrunk down. Put in our original points. I already have them graphed there for you. Now we are going to multiply the x and the y of every point by 1/4. And not all of them are divisible by 4. So we are going to get some decimals, not in W prime. When we multiply both the x and the y in W, we get the point -1, 2. Multiplying them both by 1/4. But if we do it for the next one, 10 is not divisible by 4. So we're going to get a decimal. That's 2.5 or 2.5, 0. And the next one, divide by 4 or multiply by 1/4. And we get -0.5 and -2. And there's our itty bitty triangle, W prime, X prime, Y prime. More examples. Number 5. This is graph the image of the parallelogram, another quadrilateral below. Scale factor K is 2. So the original points were not listed in the problem. So we need to name them. M is at the point -1, 3. N is at the point 1, 4. Point O is at the point -2, -1, and point P is at the point -4, -2. K is 2. It's an enlargement. we need to multiply both the x and the y by 2. So m prime is going to be at negative 2, 6. N prime is at 2, 8. O prime is at negative 4, negative 2. And P prime is at negative 8, negative 4. Connect our dots to make our parallelogram. And there we have the dilation after the enlargement with scale factor 2. Number 6, graph the image of the trapezoid below using a scale factor. K is 1/4 reduction this time. Good thing, otherwise we would run out of space on our coordinate grid. Here's our points. F is at negative 2, 8. G is at 4, 8. Point H is at 8, negative 4. And I is at the point negative 6, negative 4. Multiply both the x and the y by 1/4. We're going to get negative 0.52, 1, 2. Look at how tiny it's getting. 2, negative 1, and negative 1.5, negative 1. There is the trapezoid after a reduction with a scale factor 1/4. Let's look. Ooh, they already have it there for us. The original without the primes, and then the image with the primes. So that's a reduction. It got smaller. Let's write down the coordinates. Point D is at the point 0, 6. D prime is at the point 0, 2. E is at the point 6, 0, while E prime is at the point 2, 0. And F is at the point negative 6, negative 3. F prime is at the point negative 2, negative 1. So to get our scale factor, we need the ratio of new to original. And we can take any pair of x and y. I use that first point, the y values. The x's aren't going to do anything because they're 0. So 2 divided by 6 reduces to 1/3. That's our k value. In the next one, look at the w, x, y, z, and the w prime, x prime, y prime, z prime. It is a trapezoid, and it got larger. It's an enlargement. Our points. W's at the point negative 2, 2, whereas W primes and negative 8, 8. X is at the point 2, 0, whereas X primes at the point 8, 0. Y is at the point 1, negative 2. Y prime is at the point 4, negative 8. Z is at the point negative 1, negative 1. And Z prime is at negative 4, negative 4. New divided by old, pick any pair. I picked the 8 and the 2. The Y values, could have picked the X's in the W prime combination, but those have negatives. Let's not do that. So 8 divided by 2 is 4. Scale factor is 4.